Best time to buy and sell stock. You are given an array of prices where prices of I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. I created a visual representation of the examples here. Notice the buy price is always lower than the sell price. We always buy, then we sell in the future. The brute force solution uses 2 for loops. For every index of I, we scan every element to the right of it. We buy on index I and we sell on index j, which is always I plus 1. As we loop through the array, we can check if the current selling price and the current buying price creates the greatest profit we've seen so far. The time complexity is n squared because we have to iterate and process every index of I and index of I plus 1. The space complexity is O of 1. The optimized solution uses 1 for loop. The key is to use a dynamic buy index. In the previous solution, we blindly scanned every element of I and I plus 1. This repeated work is redundant. In this diagram, notice that number 1 and number 2 buy choices. Both are valid choices, but we are only selecting for the lowest. In this diagram, do you see that buying the lowest price would result in a maximum profit? As we loop through the array, we can check if the current element is the lowest buy price we've seen so far. Then we calculate the current profit and compare it with the global profit. After going through every index, we should be able to return our maximum profit. The time complexity is O of n. We only process each element one time. The space complexity is O of 1. We only store a variable for the min buy price.